Suppose a of n, so some sequence, equals 4/5 to the power n plus 3 over n minus 9 for positive integer n. So any sequence is always going to have a domain of positive integer n, because remember, n is just a term number, so n will be 1, 2, 3, 4, 5. If n is 5, it's the 5th term, and so on. If n is 6, the 6th term. Find the limit as n approaches infinity of a n, and as in the term. We're not finding the limit of the sum of the series, we're finding the actual, what the terms turn into if they approach a limiting value, the actual terms in the sequence themselves. Do they converge to a finite value? So we need to find the lim as n approaches infinity of a of n, right? Which equals the lim as n approaches infinity of 4/5 to the power n plus 3 over n minus 9. So we find the limit of all of that. Okay, so we can use the algebra of limits theorems. So basically anything that you've been able to do in the past with functions, you can also do with sequences. So we have a limit of a sum, so we've got 3 different things being added together. So we can say the limit of the sums is the sum of the limits. So we can do all 3 of these separately. And also we can pull factors out. So of this one I can say, well, this is 3 times the limit of 1 over n, or limit as n approaches infinity. This one I can say this is minus the limit as n approaches infinity of 9. It doesn't, not necessarily that important for the last one, but I'm still going to do it. So now this equals the lim as n approaches infinity of 4/5 to the n plus 3 times the lim as n approaches infinity of 1 over n. So this is useful because that's the standard result, minus the lim as n approaches infinity of 9, right? So you should know that the limit as n approaches infinity of 9 will just be 9. So basically this is just a sequence with every single term being 9. The fact that n is approaching something has no impact on the 9s, because it's just literally a sequence of 9, 9, 9, 9, 9, 9, 9 forever up into infinity. So this is just going to be 9. This one we know as n approaches infinity, well, 1 over n approaches 0. It's one of the first things we learned on the course. This one is a bit more tricky. It's really a geometric sequence if you think about it, because you've got 4/5 to the power n. So think about it, the first term would be 4/5, then you'd have 4/5 squared, which would be 4 squared over 5 squared, then you'd have 4/5 cubed, and so on. So basically, whenever you've got a sequence like this, a geometric sequence, whereby this number is between 0 and 1, or the absolute value of the number is between 0 and 1, then those terms are just going to get smaller and smaller and smaller, and very quickly they will be so small that they will just be negligible. Imagine 4 to the power 20 over 5 to the power 20. The 5 to the power 20 term is going to be so much bigger that it's just going to completely wipe out the bit on the top and just make the number really, really closer to 0. So the lim as n approaches infinity of 4/5 to the power n equals 0. And the reason for that is because 4/5, well, the absolute value of 4/5 is less than 1, but it's greater than or equal to 0. So if it was 0, obviously it would approach 0 then as well. If this number was bigger than 1, so say that was 5 over 4, then the terms in this sequence would just get bigger and bigger and bigger and bigger, and it would definitely diverge. But we've got that limit. I'll just write down the other limits as well. So the lim as n approaches infinity of 1 over n equals 0. We know that is a standard result. And also the lim as n approaches infinity of 9, well, that just equals 9. So the limit as n approaches infinity of an equals 0 plus 0 minus 9, 0 plus 0 minus 9, and that just equals minus 9.